Okay, in this question, you have this metal plate that's submerged in water, and one side is exposed to a flow of moving water, and the other side is attached to a brick wall. So there's no water flowing on one side, and there's water flowing on the other side. We're given the rate of flow, we're given the dimensions of the wall, so we know we can find the area of the wall, and the question is asking for the force exerted on the wall. So because you've got flow on one side and no flow on the other side, there will be a pressure differential. There'll be a change in pressure or a difference in pressure between pressure on one side and pressure on the other side. And to calculate that change in pressure, we use one of Bernoulli's equations. Now, Bernoulli's equation is this massive one here with all these different terms. So you've got P2 on one side, P1 on the other side. So if we call this side of the wall side 2 and this side 1, so side 1 is where you have the flowing water, and side 2 is where you have no flowing water. So this V, which is the velocity of the water, that would be 0 on one side. And on the other side, it would be 3. Now this raw Gy, that depends on the depth of the water. And here we haven't been given the depth of the water. But I think because Y1 and Y2 are the same, that is, they said it's completely submerged in water. So it doesn't mean we have one level on the left and one level on the right. No, it's the same level. It's completely underwater. So all of this is underwater. So Y1 is equal to Y2. All right, so Y2 and Y1 are the same. And the density, rho, for water is the same on both sides, I assume. And the density of water is 1,000 kilograms per meter cubed. You should know that, but it's given in your formula sheet, okay? It's called the specific gravity of water. So the density of water is 1,000, that's rho. G is the gravitational constant, but it doesn't matter because this is the same as that, so we can subtract it from both sides. This is exactly the same as that. And this is 0, so it disappears. So really, your equation only has 3 terms, P2, P1, and half rho times velocity squared. So we can rearrange that by bringing P1 to the left. That means subtracting P1 from both sides. And then just substituting 1,000 for the density and 3 for the velocity. That gives you 4,500. And that's the change in pressure, or the difference in pressure between side 2 and side 1. So let's call that delta P, or P2 minus P1. Why is that useful? Because the question is asking for the force, and force is pressure times area. And we've just found the pressure, and the area is really easy because it's a rectangle, so you just multiply the length times the width. So pressure times area. The pressure, we're going to use the value that we just found. Area is just the product of the 2 dimensions, and that's going to give you that value there, 196,650, and because we're looking for a force, the unit is in Newton. So that's your final answer. I hope you found that helpful.